Hey everyone, welcome to my channel. My name is John McDonald and I love working on electronics projects and anything that flies. My first project here is taking a security camera and trying to turn it into a pan tilt mount to be used for various projects. One example of something similar is shown here where the camera tracks the user based on their GPS location. This is one thing I could replicate, but another thing I kind of want to replicate is maybe tracking planes in real time. So here's an app that I made that tracks planes in real time using their ADS-B data from their flight transponder. And so that's something similar I could do, but there's a whole world of possibilities, honestly. Over the past summer, I made a similar pan tilt mount at an internship at the University of Maryland UAS test site. Here you can see a CAD demonstration of how it would function using two servos, a belt, and pulleys. And you'll notice it does not have continuous rotation, as shown here. The software to control this was written by me during the summer. It would take position and orientation data from the drone's flight controller and turn that into data for the servos in order to control the pan tilt mount, as you can see here. Here's a video of me taking it out into a parking lot to test it out, pointing it at a pole as its target. You can see that it always points the antenna at the pole, no matter how the stick is oriented. And you can see it flipping around there. In order for it to track a object in 360 degrees, it must at some point turn around, because it cannot continuously rotate. That's one thing that the security camera can do, though. It can turn completely 360 degrees as many times as you want using something called the slip ring. In this video, I will show you how to control the stepper motors inside of a security camera's pan tilt mount in order to have the pan tilt mount rotate around and around and around. Now, I already have taken apart the security camera, so I'll just show you the pieces I have. Here is one of the main bottom plates of it. You can see how the pan tilt part of the security camera attaches to it there. It has a lot of big capacitors and a cooling fan to keep it from overheating, as well as a micro SD card, which I took out and found this amazing video. Lots of fun. Here are the golden strips that attach to the pan tilt mount with these little spring-loaded pieces there. There's a large piece of metal there on the bottom, which everything is attached to, but surprisingly enough, it doesn't seem to be used as a heatsink or anything. Also, here is the big base of the security camera, the site that everyone might recognize, and only $6.99 for all that. Can you believe it? Now here we have the actual fun stuff, the pan tilt mount. And there's the stepper motor that controls the tilting motion. It's got quite a large gear reduction. On the other side, we have an optical sensor that detects when it's hit the endpoints, I suppose. I'm not entirely sure why this is there. It has 4 pins on the cable, 2 of which I'm assuming are for power, and I'm not sure what the other 2 are for. I thought you'd only need 1 more cable to serve as the signal, but maybe there is something here that I'm not fully understanding. You can see that the entire mount can rotate in full 360 degrees, which is very convenient for a lot of different projects. Again, the stepper motor that rotates this around has a very large gear reduction. That'll mean that it'll have a lot of accuracy, but it'll move quite slowly. You can see here that the cables in the slip ring just go right through the center. Essentially, a slip ring is just a metal disc and some brushes. The metal disc will be attached to the base, and the brushes will be attached to the top part. With the brushes resting on the metal ring, it'll always be in contact when it rotates around. This is good for power delivery, but it can have a lot of issues when delivering signals and or RF. Luckily, this one seems to be in good condition and rotates quite freely. Here's the board that I pulled off of it. This originally controlled the steppers. It was mounted like so. I looked online and could not find any details on this, so it must have been proprietary to the security camera. I did not get so lucky, so instead I will have to make my own servo drivers for this. Here's the camera that I took off. It seems to be somewhat low resolution as shown by the video before, but it does have quite a bit of zoom. This is a modular type of camera, and I actually looked online, and there are 4K variations that I could possibly buy and put on here. I might consider that for the future, but they're a little bit expensive for me right now. Here are the stepper drivers I will be using to control it. They are the TMC 2208 version 3, made by Big Tree Tech. You can see they are quite small, but they can produce a couple amps and should be more than sufficient for this project. Here's the initial schematic I will be using to control them. I have the black wire as ground, the green wire as 3.3 logic voltage. The blue wire will control the steps, so every time that pulses on and off, the motors will make one step. The purple wire controls the direction, so when it is high, it'll go in one direction, and when it is low, it'll move in the other direction. The brown and red wires will carry power from the power supply directly to the steppers. There's a capacitor on there to prevent voltage spikes that could potentially burn out the controller. And finally, the 4 orange wires will control the stepper motor. Now it's time to begin building it. I will be building this on a breadboard for now, just so I can quickly and easily change around the setup if needed. Eventually though, I will solder it all together. The motor I will be initially controlling is the pan motor, the one that turns it around. But once I get the setup done, I can very easily replicate it and then just plug in the tilt motor. Now, with our Raspberry Pi all wired up to the stepper drivers and connected to the motor, it's time to format the Raspberry Pi SD card and load on an image of Raspbian onto it. After the SD card is loaded back into the Raspberry Pi, we can boot it up and try to begin. Once booting up the Raspberry Pi, I had an issue with the keyboard and mouse, which did not seem to be working. After a lot of trial and error, I only later found out that only one of the micro USB ports on the Raspberry Pi is used for power and the other one is used for data. The first time we boot it up, we will have to use a computer monitor, but after that, I would like to control the Raspberry Pi through SSH, which is much more convenient and does not require a monitor. So in order to enable SSH, you must click on the Raspberry Pi logo in the top left of the screen, go to Preferences, and then Raspberry Pi Configuration. From there, click on Interfaces, go down to SSH, click Enabled, click OK, and then reboot, and SSH will be enabled. Now, let's SSH into the Pi. While it is ideal to use the actual IP address of the Raspberry Pi when trying to SSH to it, if you only have one Pi on your network, you can just use raspberrypi.local. The default username will be Pi, P-I, and the password will be raspberry. The first things you will want to do after SSHing in is running sudo apt update and sudo apt upgrade to make sure that all the packages and drivers are the latest available. Make sure to follow this up with a reboot, otherwise some of these changes will not take effect. Once that is done, we're going to want to verify that Python is in fact installed. We can do that by typing which Python. So it looks like we have both Python and Python 3 installed. We're going to want to make a folder to house all of our files that we will be working with. So let's do that. Let's try to make a hello world file too, to test that Python is in fact working properly. So let's just import the GPIO package. And then print out hello world. Now, after running it, look at that, it works. Here's my first attempt at the program, in which I set up pins 26 and 11 as GPIO outputs, and then I set pin 26 to low, which is the direction pin. Then I have a for loop that'll run 10 times, which will set pin 13 high and then low in rapid succession to try and step the motor. Let's see if this works. And I'm going to hold down the pan tilt mount to make sure it doesn't go crazy. But surprise, coding error. Out is supposed to be in caps. And surprise, another error. Let's quickly fix that one up. Now our program is finally actually turning. Let's try to add some more steps, increase the frequency. Nothing. Let's double check our connections to make sure everything's good. First things first, we're going to check the current to the stepper motor. I just have to connect the multimeter to the negative of the power supply and the little metal head on top of the potentiometer there. And this is on a scale from 0 to, I believe, about 3 volts or 2.5 volts. So 1.2 is right about in the middle. So it's giving about 50% current. Let's see what else we can check. Let's try increasing the voltage to 12 volts. The stepper driver should be able to handle 12 to 24 volts, so 12 volts should be no trouble. Let's see if that's enough to get this going. Again, when running it, no movement. At this point, I was starting to second guess some of the connections on the board. Here I'm adding an LED to make sure that the Raspberry Pi is actually sending a step signal to the driver. So every time the LED lights up, it should be stepping. Now I'm second guessing which pins on the board I should be using. that dim LED is probably just from a floating pin, so I know that there's an error there. There's two types of pins. There's the GPIO numbering, and there's also the straight pin numbering. So the pin numbering goes like, 1, 2, 3, 4, 5, 6, all the way up to, I think, 24. And the GPIO numbering is slightly different. So I was thinking that maybe I was using the wrong numbering here. There we go. Now it's flashing. All right, let's wire that back up. Now I'm checking continuity of the motor. After rereading the manual, I am now changing one of the settings pins on the driver to change the type of stepping. So I'm changing it to a quarter step and an eighth step by adding these extra pins to the ground or positive terminals. Also, while looking through the manual, I realized I did not hook up a ARM pin. So now I connect the ARM pin to VCC, or the power coming from the power supply. And now when I do that, the motor locks up, and I know that at least something is working. But since it's not spinning, I am increasing the voltage now to see if I can get it start spinning on 24 volts. The stepper driver can handle the 24 volts, but the capacitor I'm using is only rated to about 18 volts. I'm surprised it lasted this long, honestly, because it's about to explode. And there it goes. I should have been more careful there. Time to clean this all up. Now that I know that the stepper driver is sending power to the stepper motor, and that the stepper motor is stepping, the next step is to just change the wiring so that each pole of the stepper driver connects to the proper pole of the stepper motor. And as you saw there, I was able to finally get it working. So there we go. Stage 1 is done. It's so fun watching that. This thing can spin a full 360 degrees, and it's just so satisfying watching it turn around. I'd love to see this thing tracking planes in real time or something else pretty cool with a high power zoom camera. Stick around to see how this turns out. Bye.